Thank you for coming. Hope you are enjoying the conference. My name is Z. I work at a company. It's called Apiary. What we do at Apiary is we basically create tools for developers, for people who are developing, designing, and consuming APIs to help them, doing their job to build great APIs. And today, I would like to talk about, and I would like to share with you what I have learned over the years working with API vendors, with the companies who are developing or consuming or designing APIs. And I would like to tell you about the API flow, what I think is a good way to build an API. And hopefully we'll see that it is not just writing a server. It is really much more than just producing a code. So let's get to it. So first, how did we get here? How did we get to APIs? Is anybody of you here familiar with the name JCR Licklider? Does anybody know this person? He was a guy in the 60s. He's really a grandfather of internet and one of the key person in the ARPANET evolution and what we now have and what we now know as the internet. And he, back in the 60s, came with this idea. In this paper, he was talking about this intergalactic network, a big network spanning multiple galaxies that connects the different sapiens being. And he had this question. The question was, how would completely unrelated beings communicate? Beings that never met each other. Anybody here has an idea how they, talk to each other? No ideas? Well, the answer is very simple. They would have to figure out, right? Because they don't know each other. They would have to probe each other and sort of build some shared understanding, build understanding what that other entity understands, and then use that shared understanding to communicate together. Now, fast forward in 2016, we have this intergalactic network of computers and distributed networks and components in these distributed networks. And the question is the same. How do these components communicate, right? Well, the answer would be the same. They would have to figure out, right? Probe each other, establish some shared understanding, and then use the shared understanding to communicate. Well, we figure out there is another way, right? Have some a priori understanding that is shared between those components before they meet, right? And that would work somehow like this. A component would expose an interface. Then some good person will come and document that interface, write a lot of documentations, right, to explain what is going on in the interface. Then somebody else will come, read the thing, and program another component that uses the first component's interface. We call this other component client. And this is API. So what it really is, it is a shared understanding ahead of the time before the components meet each other. They are given this godlike knowledge about each other. They are not figuring it out. So if I would write it on this sort of flow line, I would say expose the interface, write the docs, read the docs, program the client. I'm pretty sure everybody knows that. Well, this is the reality, right? Some smart, person exposes the interface. Then a unicorn will come and, document the thing. And then somebody is trying to use it. Probably she will fail. Then she goes back and read the documentation. So this is this is APIs in 2016. But it's really, development, delivery, consumption, and then hopefully some analysis phase where you look at what happened and you iterate again on this flow. So this is where we are now. And this is a lot of problems, right? First, of course, it is error prone. There is so much human work involved in that people are just simply, making mistakes. Then these interfaces or these components of distributed systems are really tied closely together, because you are sharing something ahead of a time good luck, changing it later. So, if you change it, you get a broken client. If you want to change it in some way that you don't break the client, you are coming up with crazy ideas how to version the thing, right? Like, I'm sure you guys know Facebook Satellite. All right, we are not going to change the shared understanding for 2 years. You guys can be, rest assured, program your clients, tie them together, the thing won't change. Well, it prohibits the evolution. You probably don't want to live in that world. Next, it requires a couple of iterations of this flow to get this thing right, because usually when you expose an interface, the clients in the end ends up using it in a very creative and different way than you have expected them to use. Now, that might be somewhere fine, but sometimes you want them really to do something else. So you probably iterate a couple of times on that flow to get to the interface you really want. Well, and last but not least, it doesn't scale, right? Back to the communicating with aliens problem. If those components would just figure out, you don't need humans writing the documentation and stuff. There will be less room for errors. It would scale like infinitely more, right? Unfortunately, until we have the components that are smart enough to figure out how to talk to each other, we are stuck with the APIs. But the good news is, we can, address or work around most of these problems. So here is the API flow, which I think is really a good way to work with the APIs and to develop an APIs. And it is really based around one main thing. And the main thing is a design-first approach. Now, back in '99, where APIs were a new thing, they were sort of like a byproduct. You were programming or developing a distributed network, a distributed system, and you just happened to need an API there because you wanted to do the thing distributed. And so it was sort of a byproduct. You just needed an API, an interface between the components. Then later on, people have realized that it might be good to document it. Now, we are lazy programmers, right? We don't like to write a lot of documentation, so the auto-generated documentation out of the code was a big thing because it saves me the work, right? It saves the guy who is documenting the API, a lot of work. Well, guess what? The documentation suffers, right? And then somebody else comes later and needs to understand the API. So really, your API is only as good as its documentation. So you really want to have a good documentation. Now, we are finally, in 2016, getting to a situation where API are treated as a product, and they are designed first. So you first think about your API before you start, doing, development and consumption of the API. So the important thing here really is, like, if you think of an API as a product, you should really treat it as one. So, we develop software, we know how to treat it. We do, research, we do designs, we do prototypes. The same applies to API. It is really a product. So, upgrading that flow you've seen before, I just put there the design phase at the front. It's still a linear flow, and I would even argue that there is something like a preparation that needs to be done before you start designing API. And if you do it, you can significantly improve developer experience, both within your company and with your APIs users. But this is still a waterfall, right? If you design something at the start, you have to go through all these steps, learn at the very end. After some consumers, some clients will actually use the APIs. You will learn at the very end, that there are some mistakes, there need to be some changes done to the API. So how can we fix this? My suggestion here is to prototype very quickly. And actually, you can prototype in a design phase. So at the very moment when you have your design of your API, like your sort of blueprint of what you think you want to build, you can already get a prototype, a stub implementation of that API, and you want to play with it. And since you have it, you can skip the development and delivery phase. And if you have a stub implementation of your API, you can start writing a client at the same time. Ideally, you want to do both at the same time, like development of the backend and development of the client, right? Now, in 2016, in the design first approach, you can really do this. Just design your API, use a stop implementation without writing any code. And maybe you will never write the server backend. You will just write the client, and you'll figure out that it's all wrong. And that comes to my next point that you really want to analyze in every of those phases. And analyze and go back to the design, reflect that in this design phase. So this would be sort of a flow and the phases of the flow in a nutshell. It's no longer a waterfall. You are free to sort of modify and improve your designs, your API designs, and really move faster. It really moves the sort of first moment of truth, to as soon as possible. You want to do this before you start, implementing the thing. I know we love to code, but I really urge you to sort of think first. Now, every of these phases consists of several steps, and let's look at these steps in the details. The first phase, the preparation, is actually the one most underestimated phases I ever seen in API development. And it starts with what I think the most important step, and that's the definition of a domain semantics. What things are. Is this a chair? Is this a chair? Is this a chair? Well, I definitely can sit on this, right? But you need to, in your organization, with your clients, have a shared understanding of what the things are, right? How do I name things? Like, you might be like, oh, this is very simple. Everybody knows what chair is, right? This is not a chair. Well, maybe for somebody it is, right? And you just want to make sure that you are on the same page here. Like, I have a guy from a big American news corporation. He's an architect of an APIs there. They run a lot of departments, from the news, from TV studios to online media, and he's like, oh, so one organization or one team, they call this thing the article. The other team calls it the copy. The other team calls it the blog post. In the end, those are maybe the same things. What is an author? What is a person? What are the attributes? These sort of kind of things in your application, whatever is your domain, I'm pretty sure if you grab your people, sit together, and start trying to name things, you will find out very soon that you will be arguing what the thing is and what the thing isn't. So make sure you are on the same page with everybody when you are building your API. Next, also very ignored step, architectural style. Well, today everybody is talking about REST, right? It's easy. We do a REST API. The truth is, nobody is doing REST API as a Roy Fielding in '99 projected it. Everybody is doing some flavor of it, or maybe some very different thing, and that is okay. You don't have to do REST. REST, might work for you, might not. What is not okay is choosing an architectural style and ignoring its drawbacks, and not understanding the other architectural styles. So make sure, what is the right style for your application domain. And again, there is no silver bullet. There is a good style for that, and another style might be appropriate for something very different. So, if your API is just one of thing for, I don't know, an event that lasts for just one day, or your API should last for years, there are different architectural styles you probably want to employ. One might take a long time to develop, but it will be pretty robust. The other will be right there, but good luck changing it in a month, right? And things like this. So pick the right style and make sure everybody understands the style. If you know, these styles are not enforced in any way. So if you pick a style and your clients do not understand it and they use it the wrong way, well, then it doesn't matter really. The last step in the preparation phase is formalization of a style guide. And you can think of this as a sort of coding standards of your API. So this is where you say how you will name your resources, name your URLs, camel case, lowercase. This is where you say, how do you do pagination, how do you do authentication, right? And you will reuse this. You will write it down and use this definition, because you probably, if you have more APIs, you want to use the same pagination style. If you don't, well, the consistency and the developer's experience will suffer. So that's a preparation phase, very important one, most often ignored. Design and prototype. So I'm still not even getting to designing your API. I didn't even get to building APIs, right? Identification of your resources. You have this list of terms, the semantics of your domain. Whatever you have there, it's yours. Now, you want to look at that and think about what are the resources? What am I going to expose? What are just some attributes? What are some data? What are some data I want to expose? What are the actions, right? So you want to look at it, the terms you have wrote down, and think about which one are resources, actual resources you are going to expose in your API. Next, define resource states. Does anybody know what this diagram is? It is a finite state machine. It is a state machine diagram. And as scary as it is, it's a very cool thing when you are designing an API. This one shows a message resource, and it's saying it has 3 states. A message can be drafted, it can be sent, and it can be archived, right? What is really interesting here is that in each state, the resource affords you with different actions, right? A drafted message can be edited. It affords you to edit the message. Once you send the message, you are in the send state, you can no longer edit it. So this is a state machine of one resource. And if you draw this, you will have a very clear understanding of what that resource is, what are the attributes, what are the actions it affords. And it will help you furthermore to understand the relations between the resources. Like, this is a message, this is its author, author has, I don't know, friends, etc., etc. So, look at this. Finite state machine is really a very helpful thing when you start to think about your APIs. Now, the first real work, the first after thinking, you want to formalize all these steps we've done so far. So you want to write it down. Now we have a couple of API description languages. I'm an author of one, but there is many of them. So again, pick the right one for you, the one you like, and use it. Now, I have an email there, and this is a story. 5 years ago, I was doing a cool application. I was a front-end guy doing an iOS app, and my friend Paul, he was a server guy, and I was sending him emails like this, like, hey, Paul, can we do an API that will do this and that and that? And he replied me back, yeah, but what about this response doing that? And I said, sure, but what about this? And we were back and forth, back and forth. I don't know if this happened to you. It happened to me. 3 days later, 40 emails later, right? Like, good luck. We did the API design over the emails. Good luck figuring it out, what we settled in 3 days, right? Like, reading all those emails and trying to make a mental picture of what the API should be. So please use one of the API description formats. It will really help you to get this right. And obviously, using a GitHub flow helps you there because you have a version control and you see the versions, you can discuss it there. Now, once you have the description formalized, once you have the design formalized in an API description format, you can take the shortcut I was talking about. There is a couple of mock servers. So you just take this description, you throw it into that little program, and it will spin up basically stub implementation of your API, right? So you don't have to write any code. And you can just experiment with it from the command line, from wherever you want. You can start writing a real client. And like we at Apiary, we provide you a hosted mock server. So you just write the description, and there is already your dummy implementation somewhere in the cloud. So you can take a shortcut from here, go all the way to the consumption phase, and start working on your client. Again, this is really moving the first moment of truth. So you hear from your client developers much sooner before you even start writing any server. Finally, for the design phase, share and review the thing. And I have to really stop and zoom on this one a little bit, because that's what makes a good design really a good design. Sharing and reviewing, and that's really the big difference between the classical flow we had there at the start. And I will actually talk a little bit about the GitHub flow. I hope you guys are familiar with it. It's not really the sequence of steps I like about the GitHub flow. It's not that you create a branch, you do some commits, you do pull request. What I love about the GitHub flow is the fact that it gives you clear points in the life cycle of a software where people interact with each other. In other words, where they collaborate. It gives you clear checkpoints where different personas are different doing things, and when they are engaged, when they are doing code reviews, when they are talking together, when they are programming. That's the best thing about the GitHub flow to me. It clearly says how people collaborate together. So back to APIs. You really want to involve everybody in the design process. You won't be surprised if I tell you that the best APIs are those that are understood, right? Regardless of a style or what they are about. Like, really get everybody there. So this would be the difference. There you had those people in the silos not really talking about each other. But what I'm saying here is like get everybody, to design a prototype, and get them agree on the design you have made. So that's essentially a contract. Once you get everybody agreeing on the contract, you said, this is an API I'm going to build. This is an API I want to consume. A product owner say, all right, I want really to build this. I'm committing my resources to that. And the tech writer guy is like, yeah, I understand that. I can document it. You can treat it really as a contract between everybody involved with the API. So this shared understanding in this intergalactic network becomes the contract between all the parties involved. And because it is a contract, I really suggest to put it on a GitHub in the same repo as you have the implementation. So you have a code with your backend implementation, and next to it you have this contract. And what you really want to do is keep checking, as you are developing the server, you want to keep checking that the thing is according to the contract. So one thing you can do is test it locally. We have built a tool, it's called Dread. It brings the justice to your API development, and what it really does, it spins when you run it locally on your local computer, it spins up the instance of your server, it takes the description, exercise every single thing in the description, and reports any discrepancies from the actual server. So you can sort of even think of it as a test-driven development, right? When you are starting, nothing is implemented, all the tests are red, right? Once you are starting adding these endpoints that are written in this contract, the thing will get greener, greener, greener until it is green, right? Now we are good guys here, so we use a CI. So the same thing we'll do in a continuous integration. And again, the cool thing here is you have a contract, the tests, and the implementation in the same repo. If you push the change to implementation, it gets tested. If you push the change to the contract, it gets tested. You always know, that the API is implementing what was agreed upon. Or if you change what was agreed upon, you still know whether it broke the implementation or not, right? So, it doesn't help you to, do changes as you want, but it at least helps you to understand whether you are breaking things, whether you are breaking people or not, right? And that's a very important thing here, like this integration with your contract. So your contract is living on a GitHub, and as I said, you are having a test in a CI, but if you render the documentation from the very same repo, from the very same contract, the documentation is always up to date. If you have the mock using the very same contract from the very same repo, the mock is always up to date. Same for the other tools I will be talking shortly. So the point here is really you have a single place for truth about your API. The contract everybody agrees upon using the GitHub flow. It sits in the GitHub, and every time you change it, everything gets updated. If the test fails, the documentation is updated or it is not updated, basically based on whether it will deploy the implementation or not. So you are assured all these things are in a sync. So back to development. Obviously, when you have this tested, deployed, There is a parallel talk right now in the other room where Gudmundur is discussing the Heroku flow. So you probably want to watch that as well. I do want to watch it. So deploy your server, pretty clear. Delivery phase. You just share your API description. That is really all what matters. Or you can hand out the documentation rendered out of the description. Usually the documentation has some nice bells and whistles, interactivity in it, like a language examples or console or whatnot. But it's really, again, rendered version of the API description. Finally, a good, very important thing from the delivery phase is API management. Some of the APIs do not need it. Some of them do. If you have a lot of users, you have to manage the tokens, users of your application, help desk. There is a lot of management companies who are doing a great job at helping you managing and monitor your API. So that's the delivery phase. Moving on to consumption. Obviously, sorry, there is no shortcut here. Somebody has to really, go and read the documentation. However, you can experiment, and you should experiment with the API before you start using it. And of course, you can use a URL or PO or Postman. But I would suggest you will use basically a client tool, like shown here, that is aware of the contract. Because what you see here, I'm not sure you can read it, but basically I'm doing a POST request to an endpoint. And I have forget to add a content type header in the request body. This thing is telling me that I have something missing in my request. And this thing knows it because it knows it from the contract. It knows it from the shared understanding we shared ahead of a time. It knows that I, as a client, was supposed to send the content type header. So it will help you, as a client developer, to see what you are actually sending and what you are maybe missing from what was agreed upon. So then you obviously want to develop the client. You might use just the mock server exclusively, or you can, if you have the API implemented, you can have some sort of a debugging proxy where you are proxying the calls and you still use the diff. And you see all the calls, and you know, not only if you are sending what was agreed upon, but if the server is returning what was agreed upon. So you really see what's going on, and if this was a part of the contract, or you are getting some nonsense. Finally, the analysis phase. I'll be very brief here, but it's very important. Just get all the feedback, both from the actual people who are involved in those phases, developers, clients, obviously. Even tech writer can have very valuable feedback. So listen to these people, and also, have some measurement in your applications. Very, very easily you can find out that some, endpoints are not used, or some other endpoints are abused, and you can probably, address that later when you iterate on this API flow. So this is what I think that is a good way to build APIs. As you could see, hacking the server somewhere in the middle, writing something except of a lot of text is here. So building an API is really more conceptual work than actual coding. And the more time you spend with the preparation, with this design, and the more people you involve there, the better API you are going to get. And this was a lot of information, so I have put together this little site where it's basically all the things I was talking about with a greater detail. It's hosted at Apiary.io, how to build API. We are just launching it right now, so you are the very first one to know about this. It's basically going through all these steps with a lot of detail. And yeah, so look at it. Let me know if you have any questions. I'll be happy to answer them here or later. And good luck with your APIs.